Hello, I'm Ifat, and today I will be talking about my thesis, which is titled Facies and Provenance Analysis of the Midcontinent Rift System in Kansas. Before I start, I'd like to thank Association for Women Geoscientists, OSAID chapter, for the research scholarship. Here are the outlines for today's presentation. Without further ado, let's talk about the rift. Midcontinent Rift System, or otherwise known as Keweenawan Rift System, is one of the oldest structural features on North American plate. It started at about 1.1 billion years ago due to a mantle plume origin centered around Lake Superior region. It has resulted into a 2,000-kilometer long U-shaped structural feature that starts from Ohio up until Lake Superior, where it is exposed, and from there it's continuous beneath Minnesota, Nebraska, Iowa, and Kansas, where our study is more focused. As I mentioned, it is only exposed at Lake Superior region, and everywhere else it's buried beneath younger rock. Therefore, the geophysical data such as gravitational and magnetic anomaly data, seismic data have been really helpful in terms of delineating and identifying the rift. The regional gravitational and magnetic anomaly map has confirmed the presence of MRS in northeastern part of Kansas. Also, seismic analysis has resulted into the identification of a half-graben rift basin in Kansas, which is bounded by low-angle normal faults. The only well that goes through the rift successions in Kansas is Knoll Porch 1, which is the deepest well in Kansas. It was drilled back in late 1980s in Washington County by Texaco. Berenson suggested that the encountered units in that well resembles of syn rift successions, meaning they were being deposited or accumulated while the rift was still active in this part. However, there hasn't been much study in terms of rift evolution in Kansas. That's where the study comes in. With an aim to understand the rift evolution process in Kansas, the study wanted to identify depositional environment and provenance of the rift basin infills. It also wanted to propose a depositional model and establish a tectonostratigraphic framework. Furthermore, it attempted to correlate between the different rift segments to see the differences and similarities between them. For that, we used the discontinuous course retrieved from Texaco Knoll Porch 1. Our study interval ranges from 5395 feet to the bottom of the well, which is 11,296 feet. From this range, we studied 11 core intervals that falls into 5 different sections. From bottom to top, these are section A, B, C, D, and E. Each of these sections are separated by intermittent igneous activities. To compensate for the lacking of a continuous core, we tried to use the wireline logs where possible. This study was conveyed in 2 steps. The first step, facies analysis, involved the core descriptions and identification of table from which facies associations were established, which ultimately led us to the depositional environment. For the second part, quantitative petrographic analysis, 27 thin sections were selected and each thin section were point counted for 300 points for further analysis. With the data, we classified sandstones according to McBride's scheme. For provenance analysis, we use Dickinson's method. In this method, we can trace back the provenance type using the sand compositions. Let's look at the results. Within our entire studied interval, which is presented here with this image, we identified 16 different lithofacies. The color bars on the side corresponds to that of the facies tables, where we recorded the facies code, description, and interpretations. Altogether, we identified that our study interval included reddish brown to gray, poor to moderately sorted, mudstone, sandstone, and conglomerates. From that, we established 6 facies associations indicative of their depositional environment. These are Aeolian, fluvial, lacustrine, mudflat, or lake margin, fan delta, and alluvial fan deposits. Using all this, we constructed an integrated sedimentary log where we can see the vertical facies successions and their changes. Also, on the rightmost column, we inferred the relative humidity informations from the studied intervals. On the second part, for quantitative petrographic analysis, we recorded the textural features along with the primary composition and diagenetic compositions for each thin sections. Plotting the data, we found out that most of the samples were from sandstones with minor amount of conglomerates and conglomeratic muddy sandstone. Over here, the cool photomicrograph shows poorly sorted conglomerate, bimodal sandstone, well-sorted sandstone, laminated mudstone, well-sorted sandstone with a corsal lamina, well-sorted sandstone with inverse grading. Also, for sandstone classification, we found out that most of our samples belongs to three main sandstone groups: lithic arkose, feldspathic lithironite, and arkose sandstones. Finally, for provenance analysis, we noticed that most of these were sourced from uplifted continental basement block, except for section C. Using this data, we were able to propose depositional model. The 3D block diagrams are made in accordance to the basin configuration as suggested by previous seismic studies. The red star marks the approximate location of Noel Porsche 1. Starting at the bottom, section A, we see that the depositional environment changes from Ilean to fluvial and then back to fluvial again. Therefore, our depositional model corresponds to the changes, and we propose a braided river parallel to Ilean environment. We suggest the braided river pattern as many studies have found Proterozoic rivers to be of braided, which is also agrees well with our findings. Moving on to the next section, section B. The lowermost part of section B, which we call as section B1, shows the dominance of mud flat or lake margin deposits. Therefore, the depositional model shows the backstepping of the fluvial system and expansion of the lake. On top of it, we see the return of fluvial and Ilean system once again, which we call section B2. Therefore, the depositional model shows the return of the fluvial system. Lateral to this exist the Ilean systems. At the top of section B, we see another Ilean deposit. However, there has been a huge gap between these two parts. Therefore, we do not know if the Ilean system persisted without any interruptions or not. For the next section, section C, we once again see the expansion of the lake, as is noted by the lacustrine deposit. The rest of the units comes from upper volcanic dominated successions, where we see the dominance of proximal facies such as fan delta and alluvial fan deposits. Therefore, we suggest in our depositional model, the alluvial fans, the uplifted blocks favors the alluvial fan developments. However, for section E, we do not have enough data to propose a depositional model. The changes in the depositional model and vertical facies succession shows a repetitive transgression and regression cycles. Along with this, the diversifications of sediment sources suggested by the McBride's diagram and the rearrangement of drainage basins suggested by Dickinson's diagram indicates the control of tectonics in terms of basin evolution. Also, we noted the repetition of arid and humid climate. Therefore, it hints towards the impact of climate in terms of basin evolution as well. Altogether, we can say that tectonics and climate both played important roles. In terms of tectonic stratigraphic framework, we were able to identify 3 rift sequences following the ideas put forwarded by Martins Neto and Katinuanu. According to their method, flooding surfaces are used as key surfaces. We were able to identify the flooding surfaces, which records the flooding event or increase in base level. For our study, we identified those by juxtaposing facies indicative of higher base level. We were able to identify 4 flooding surfaces, and bounded by those, there are 3 rift sequences, which is function of tectonic pulse and subsequent creation of accommodation to sediment supply ratio. Lastly, this study attempted to correlate between the rift fragments For that, at first we used geochronological data, which suggests that the rift successions in Kansas are coeval with post-rift successions elsewhere. For the second part, we tried to compare the compositions of the Noel Porch 1 sediments, and we see that the sediment composition varies widely, which is pretty common in terms of difference in basin geometry and bedrock compositions in different areas. Here are the references for this study. Thank you so much.